All right, let's take a look at an example that's more like what you would see in your homework. Here I have 7 performers. We're just going to label them A through G. Yeah, A through G, rather than giving them names and having to write all that out. And they're to appear at a fundraiser. The order of performance is determined by random selection. So just picking people out of a hat, basically, and having them perform. Find the probability that each of these 4 things will occur. So the first one is that D will perform first, then E will perform sixth, and B will perform last. They'll perform in this very particular order, and then finally F or G will perform first, one of the two. Okay, so let's start with the beginning. Now we're looking at probabilities here, and probabilities, remember, you're taking the cardinality of the event divided by the cardinality of the sample space. Well, each of these is considered an event. The sample space, however, is going to be the same in all of these. It's a total number of ways that you can permute these 7 performers. And remember, the order is actually important in this case. We're specifying particular orders, particular people in particular places. D performs first, E in 6th place, B in last place. So the order is important. In fact, all 7 of them are included in every possible ordering, okay? And so they're all going to appear. So we're looking at permutations because the order is important. And so we want to figure out how many total permutations there are. That gives us our base, that gives us our sample space. And then we can look at the particular events and then do the division, okay? So the sample space, let me see, N of S, is going to be the total number of possible permutations here. Well, we're taking 7 and permuting 7, right? 7 permutes 7. So we're selecting all 7 of these to permute. We're not taking 4 out of the 7 or anything like that. We're taking all of them. And so that's going to be 7 factorial over the difference between those factorial, which is 0. And of course, that's 7 factorial over 1, which is just 7 factorial. Okay. Now we could calculate 7 factorial. In fact, I will do that here just to check. It is going to be useful to have that value. 7 factorial is 5,040. Okay, we'll come back to that. I'll use 7 factorial generally speaking because it's easier to cancel stuff that way. But we'll grab the 740 or 740, 5040 at some point. We'll need that number too. So, okay. So part A. Maybe alternate these different colors. Probability that D will perform first. Well, let's just kind of set this up, get a visual and an understanding of how this plays out. You have, I'll call them slots, right? Performance slots. You have slot 1, 2, 3, 4, 5, 6, and 7. And then what we're going to do is plug people in and see how many choices we have for the rest. And we're going to see the counting principle kind of underlying here. And so if D performs first, I'm going to plug in D right there, right, in slot 1. Well, then slot 2, if you take D out of the picture, we have 1, 2, 3, 4, 5. We still have 6 options. So there's 6 choices here. If whatever one ends up in that spot, that's not a G, that's a 6. So my G's and 6's look very similar. That's a 6. Yeah, okay, anyway, 6 choices, followed by 5 choices. Whatever one gets pulled out here, you end up with 5 left. Whatever gets pulled out, you've used up 3, so there's going to be 4 left, then 3, then 2, and then there's 1. Kind of get pigeonholed at the end. Okay, so the number of choices at each spot gives you a product of 6 factorial. And so the cardinality of this set where D performs first, in fact, let's just call it D actually, right? Cardinality where D performs first is going to be 6 factorial. That's the number of ways that D performs first out of that whole set. And so then the probability is the ratio of this cardinality to the sample space cardinality. So the probability of D is equal to 6 factorial over the 7 factorial, right? It's this number over this number. And that ratio is, of course, 1 over 7, right? The 6 factorial on top will cancel with 6 factorial on the bottom. You have 7 times 6 factorial, and then the 6 factorials cancel. So it's 1/7. So that's the answer for part A, will be 1/7. It's a 1/7 probability, or 1 in 7 chance that D will perform first. We can go through this in a similar way with part B. We have what's the probability that E will perform 6th and B will perform last? Well, let's go ahead and plug those in. I'll keep my slots here. 7 slots, and I know E we're sticking in 6th place, and B is last. So I've got 2 of them filled in. If I take E and B out, I have 1, 2, 3, 4, 5 options left. So I'll put, there's 5 options for the first slot. Take that one out, there's going to be 4, then 3, then 2, then 1 left over. That's going to be 5 factorial. And so here, I'll call this set EB, just so it's clear what's going on. So this is the N of EB, all right? The cardinality where E is 6th and B is 7th, I guess I'll call it that. And so that cardinality is 5 factorial. And so the probability of that occurring is going to be 5 factorial over 7 factorial. And of course here I can cancel again. It's 5 factorial over 7 times 6 times 5 factorial, right? I can expand out a little bit of this. The 5 factorials cancel. 7 times 6 is 42. So it's a 1 in 42 chance that E is listed 6th and B is listed 7th. Okay, so 1 in 42 chance that that will occur. Okay, we'll switch colors again. Let's look at part C. They will perform in this particular order. Well, that particular order is only one of the possible permutations. It's the only one in its set. So the cardinality of this order is 1. As soon as I change the order, I wouldn't have that order anymore, so it wouldn't be in that set. So this event has 1 order in it, and that's it. And so the probability, I'm going to call that probability of C because it starts with a C. I don't know. Or because it's numbers or letter C. I don't know. Just whatever. And that probability is the 1 permutation, the 1 particular permutation, over the total number of permutations, which is 5,040. Knew that was going to come in handy to have. It's 1 over 7 factorial. Okay. So 1 out of every 5,040 permutations will be this particular permutation. Okay, and let's switch colors one more time. Go to part D. And I want the probability that F or G will perform first. So I'm going to clear this out. And, well, the number of ways that F can perform first is going to be F in that slot. And then there's, well, I got to figure out my options for the other slots. There's 6 times 5 times 4 times 3 times 2 times 1. That looks a lot similar to D performing first, right? 6 factorial ways there. And then if G performs first, boy, and G's and 6s, I got to figure out a different way to write G's. There, put a little corner on there. There's a G. So G performs first. There's again 6 times 5 times 4 times 3 times 2 times 1. So that's another 6 factorial. So the total number of ways that this can occur, one or the other, is going to be 6 factorial plus 6 factorial, which is 2 times 6 factorial, right? So the probability then I'll call that FG, or F or G performing first. Well, that's going to be 2 times 6 factorial all over the 7 factorial. Okay, so it's 2 of those, it's 6 factorial plus 6 factorial over the 7 factorial. And I'm going to divide out the 6 factorial, so it's 2 times 6 factorial over 7 times 6 factorial. And the 6 factorials cancel, right? 7 factorial is 7 times 6 factorial. And then you're left with just 2 sevenths. So the probability on that one is 2 sevenths. So here's all 4 of my answers for the corresponding probabilities. So probability that D is performing first is 1/7. Probability that E performs 6 and B last is 1 out of 42. Probability that they perform in this particular order is 1 out of 5,040. And the probability G, or F or G will perform first is going to be 2 sevenths. Okay, so 2 out of every 7 times we'll have an F or a G in that slot. Okay, so that should cover all of those options, and that's a really good example of using permutations. Permutations and some counting principle here in order to develop our probabilities.